This week we started off with introduction to datasets, we saw why datasets, the fact that this era has helped us collect a whole lot of datasets, and even we have good computational facilities to make sense out of these datasets. We showed you using Python, NetworkX like APIs how one can write a piece of code and make inferences from these datasets. We also told you a powerful tool like Gephi, where you input a graph and it beautifully shows you the different nodes and edges of the graph. We can visualize it in different ways. It appears very nice. Gephi is not just used to visualize graphs, it is also used to analyze graphs, especially for people who are not from programming background. If you were to analyze a given graph quickly and you want to make sense out of it in let us say no time, Python is not your destination, it has to be Gephi like tool. But Python again gives you the flexibility to write your own code the way you want. A Gephi does not, it is sort of standardized. Nevertheless, we saw a tool like Gephi which we realized is both powerful and fun to use. And then we moved on and saw a piece of puzzle which we have been discussing from the first week's first lecture, which is the emergence of connectedness. We saw how a graph becomes connected when you take a bunch of nodes without any edges and you start putting edges, one edge at a time, and you will see that there is a moment when it becomes connected. When does it become connected? If you remember, it is when you put n log n number of edges. Then we also saw that it is not just mathematically true that it is n log n, our program also says it has something to do with a little more than n number of edges for a graph with n vertices to become connected. And that talks about the power of what is called synthetic datasets. Synthetic means you synthesize a dataset of your choice. For example, you have a huge dataset of 2000 nodes or 2 million nodes, let us say, but you want to observe what happens on a graph of 100 nodes. So you would like to create your own network of 100 nodes. The experiment with which we concluded this week was a typical example of how one can do this. You saw the plot of as you take vertices and you look at the emergence of connectedness, and the plot has something to tell you, right. So that's a good example of how you can make your own data sets as and when required. There are many ways to do this, we will cover that in the forthcoming chapter. To put this entire chapter in a nutshell, we learnt about data sets, we saw the emergence of connectedness, and we saw the importance of synthetic data sets. That is with this week. So next week onwards we are going to shift our gears completely. The past 2 weeks has only been playing around with Python and understanding some basics of NetworkX and crunching data sets and things like that. Next week onwards we are going to see some hardcore results in network science. So all that I told you in the first week's lectures on do you think you should watch your company, how does Google work, how do you predict who is your next friend, so on and so forth, all those things are coming next. So next week especially we are going to start off with a clip of Harry Potter and we will see what has one to learn from this clip.